Hey everyone, it's been a while. I wanted to create a video on what Git is, how I use it on a day-to-day basis as a data engineer, and help people who are just getting it started in the industry. Maybe you've just recently graduated with a computer degree, engineering, science, whatever, or you're transitioning into the world of tech and software, and you keep hearing about Git, but you don't know what it is. So this isn't going to be a super in-depth, everything that there is to know about Git. We're not going to look at the source of Git. We're not going to get into the very super details, but just a working practical knowledge of this popular source control system called Git. So what is Git? Git is a source control system. So when teams of people are checking in, are working on a project and need to put their code in a central place, they use a source control system. Um, Git is a popular one for that. It's not necessarily just for teams. You can use it as a solo person, just yourself, to make sure that you can go back and forth between different ideas. So it's kind of got a foot gun insurance to it, where if you screw something up, you can go back to a branch. We'll talk about that, or a point in time in the past. So that's basically the value that it adds. What it is it works off of the the code or the objects or the files that you give it, and at every it, it works on this concept of snapshots. So um, let's say you have a piece of code and you check it in. All of this stuff I'll explain, but you check it in and you have um, let's call it a main branch, a branch that is um, something that will serve as your source of truth. And then you want to make a change, but you don't necessarily want to break what's there. You don't want to break other people who are looking at main. You just want to do your own thing. What you'll do is you'll branch. And that branch is a snapshot of the code and all its history at that given time. So when you create a branch, you're basically taking a snapshot at time. You can do your changes, you update your changes to that snapshot, so it's now diverged, it's different. And then when it comes time, you will push those changes back to main, given some process, some formal process. Most teams have their own process, and that's how the workflow works. You will. It's kind of like a cycle in that sense. So it's enough words. Let's talk about it with some code, if you will. So here I have a repository. It's got a Git this is a Git repo, so it has a Git folder here. We can just start over, so to show you. So most of the time in a professional work sense or space, you have existing repositories. And so you'll often do some sort of git clone a URL here. We won't necessarily, we will do that actually. I have a repository that I have here, and I will clone it. I have given GitHub my personal SSH key, so I can use Git via SSH without having to use passwords and whatnot. That's outside the scope of this this video, but it's easily Googleable to add your private key to a Git project. This is my own name, my own project. But in a work setting, you'll be given the ability to add your own key and be able to download or clone the projects that you have access to. So let's do that here. Git clone. Nope, that's not it. Copy, paste. All right, so now we have the, actually, you know what I'm gonna do? I'm gonna do this. going to, and then I'm going to clone it again, just to clean up the file system for me a little bit. Okay, so so we have the stuff here. This is, if we look, so the first command we did was git clone. This is how you get repositories. This is how you bring down a version of the data. It's 99% of the time, I generally just do git clone and whatever the URL of the thing that I'm cloning, or whatever the URL of the Git repository, be it a GitHub repository or a GitLab repository, etc., that I'm trying to get. So now that I have that, you can see that we have some files. So now what I'd like to do is let's add a simple Python file here. So I'm using LunarVim, so let's do LunarVim hello world. Let's do def hello. This is so trivial, but name. This is a string. This returns none. Print f string hello. Name. Oops. Name. Yeah. Gosh. Name. Okay. Now. Okay. Hello. Let's make this fun and a little dangerous. Let's do this from the command line a little bit. Oops, I haven't mapped my caps lock to escape on this machine. I should fix that later. So name will be sysargv1. I think any security folks on the outside will probably be looking at this and screaming. This is a huge security bug because this is not escaped. And if there's any way to get some malicious input here, they could totally bork my system here. So don't use this code. This is just to make it fun, I guess. You know what? Let's make this better. So let's do this. Man, that's actually killing me here. Okay, so let's do this instead. Let's get let's do this. I don't know. This is kind of dumb. Person name. Let's do name. Okay, so there'll be an environment variable where it'll be name, and I am going to print that name here. Oops. And here. And let's give it a default of world. Pretty sure that's how that works. Let's make sure. Yeah, a default. Takes a default. Cool. All right, so we have all this. That took way too long because this is a quiet keyboard. I figured it might be better for the video. I'm not quite used to it. So it doesn't really do too much. Okay, cool. You know what? Actually, yeah, fine. And then what we'll do is we'll write this. Okay, so anyway, so what do we have here? We have untracked files. So what Git is telling us is, hey, these files have changed, but they're not added to any mechanism by which I'm tracking them. And they have to be added to the stage, if you will, before they can be a candidate to be added to your branch. But we haven't created a branch, you might say. So what we should do here is, I wonder, yeah, that's so much better. So anyways, okay. So this is a shell that this is ZSH. I don't usually use GNOME, and GNOME defaulted my login to Bash for some reason, but ZSH is usually what I use, and I've added some prompts to make it nicer for use. The X here, you can see it shows that there are changes that haven't been staged. This is telling me what branch I'm on, and then I'm doing some Git stuff. So let's look at this again. So we saw Git clone, we saw, and we've seen status so far. And then we did, so you do your edits, blah, blah, blah. This needs to be added, git add hello world. Okay. Now it's been changes to be committed. Kind of holds your hand here in a second. Also, it gives you the code or the command to unstage something. If you don't want to add it, if you want to add it, you want to just maybe get rid of it, you can unstage it, and it will be as if you didn't add it. So let's actually commit this. So we will do git commit. You know what? We should do this properly. We need a branch. So this is another thing that you will see. So we've seen git clone, git status, git add. Now we actually need to create a branch. So what we'll do two things at once. You can create arbitrary branches, but you don't usually check out or create many branches without checking out that branch. So in my workflow anyway, I always create a branch and then I immediately need to check it out because I want to work on it. So you can do that pretty easily by just going git checkout. I want to check out a branch, but in fact, I want to create a new branch to check out. So let's create a branch. Let's call it tutorial. So now I'm in a new branch called tutorial. And doesn't have anything in it. If we look at log, see the git log is kind of a log. It's a history of all the things that have been done. So this git log -p is like it creates a patch. Fun trivia fact: the Linux kernel from which Git was created by Linus, the creator of the kernel, was the kernel is developed, or at least until recently, I'm not sure if it still is, but by sending patches across. So what they will do is they'll use Git, they'll make all their changes, and then they'll create a patch set of this and email those changes around. And people who want to add those changes in will take that email and manually patch that stuff in. It's quite crazy, so I think. But anyways, most people are using some sort of central Git service, like a GitHub, to make that a little bit easier. So, okay, so what can we see here? We can see the README that was added. And then we can see the license and the README, okay? Now we want to add this file. So we've already staged it, git status stage. So it's here, ready to be committed. Now we commit it. Now, there's a few ways to do this. I like to do it from the command line. So git commit -m, and you can chain many messages that you'd like. So it's git commit -m. The first one, at least in the GitHub world of things, is usually your 3 to 5 word title for the message that you will see in your Git log. So it's good to have like summaries here, and then you can go into as much depth as you want in subsequent messages. So git commit -m, add initial file for video for training. Another M, add silly Python file to make modifications later. Okay, cool. So what do we look like here? Or what does it look like here? So you see these two lines. The first line, at least on GitHub, will look as the title kind of. And then it will have the message down there at the bottom. So what do I need to do now? I need to push this. And by default, automatic pushing to set up the remote destination for your local setup is not set, and I like to keep it manual. It's fine, doesn't matter. So now I have a new branch that's set up, and GitHub here on the side already knows that I need to make this. I probably want to set this down or merge this into main. So this is a GitHub mechanism, a GitHub idea called a pull request. So we create it. Let's go in here and create a pull request and see how the first line became my title, and every other line becomes part of the body. You can think of it like an email. There's a subject and a body. So I'm going to create a pull request. I want to make these changes into main. You can see that here. I want to commit one. I want to merge one commit into main from tutorial, from the branch. So let's look at the files changed. It'll show us the changes. And this is all the stuff that we've done. I'm going to review the changes, submit review. Okay, but since by default GitHub won't let me accept my own changes, but I can, because we don't have anything set up by default, I can still merge this stuff myself. So anyways, so now I don't necessarily need this branch here, so I can delete it. Boom. Okay, cool. Now, what happens on our side? Nothing happens on our side. We have the branch that we have, and we have the branch that we had originally. Remember, this is snapshots, and only when they sync and when they sync manually do the changes get do they show up locally for you. So if you go now, we don't have the file here, but if we pull, it will pull in the file that we've added, and you can see it here. Okay. Now, another thing to look at is git branch-a. Don't mind this diff tool thing. I tried to add a fancy diff tool, and I borked my git config. It's fine. It doesn't matter. So we have the branch here and the remotes tutorial, but this needs to be cleaned up because it's actually deleted on this side. So I will just delete this local branch. Oh man, helps to spell correctly. Okay, so now we're clean. So we're good to go. One thing I wanted to show you is what happens if I wanted it to emulate what would be if you were working with someone else, and what you should do on a beginning basis when you sit down to your desk for the first time and you want to look at you want to start working. Well, there might be changes that have happened that you don't know of or haven't gotten yet, and you want to track all the changes that happen to main. So I'm going to edit this from GitHub itself, and this is going to look like a change that someone else has posted, but I won't have it here. I won't have it locally yet. So maybe maybe I get a ticket or something that says make this less dynamic or something, and actually hard code this for some reason. So okay, so be it. We're going to commit this change, make it less fun. Nope, that's actually a terrible git commit message. Per ticket 1, 2, 3, 4. You might have a ticketing system. Remove the ability to remove the ability for hello, the function hello to take an argument, making it static instead. Here you can also say stuff like this fixes problem XYZ, customer ABC requested this. All kinds of context and things that you want to add. Anything, you know, if it's like Bob from accounting really wanted this. All the questions that you might have in the future, you can write yourself a note here and you'll thank yourself in the future. So here we can commit directly to main because I don't necessarily want to go through the whole new branch dance again. Okay, so now this has been updated. Now, of course, we don't have these changes here. So on a daily basis, what you're going to want to do is this, git pull. And we see these changes. So let's look at these changes. Here's what happened. Hello world got changed. You can see the versions of the files. You can see the commit message. So pretty cool stuff. So that's the workflow. You start up, you crawl out of bed, you fire up the computer, go to your repository, hit git pull. Make sure you have the latest stuff. Then when you go to branch something, you know that when you're branching off of main or some tracking branch or whatever it is, you have the latest versions, and you're much less likely to run into issues, merge conflicts, these kinds of headaches in the future. So what commands have we done so far? We've learned git clone. We've seen git add, diff, log, commit, push, and pull. And what's crazy is these are the 7 commands that I use on a daily basis. And it gets a little bit more advanced from here. Sometimes 2 or more engineers will be working on the same file. And when someone goes to merge this, their changes, there might be what's called a conflict, and you'll see it. And when that happens, don't panic. Just poll the team or find whoever else has been working on the same file and come together, pair on a way to resolve those conflicts. I'll show you some cool other commands that you can use. So git blame. Blame is a kind of a harsh way of looking at who made changes, but it's a pretty cool tool to see who made changes to a file. So since I'm the only editor here, I made all the changes. But you can imagine if this was someone else, and oh, actually you can, right? In Git land, I guess, it doesn't have my full name, but here on my workstation it does. So anyway, so imagine this was a different person, and you both have changes to this file. Then you can find that person, track them down, and get into send them a Slack message or fire up a meeting or something and ask them, hey, I made changes here, you made changes here. Imagine this is a more complicated thing like a computation, and you're doing an exponent at 5 and they're doing an exponent at 3, and you're trying to figure out what it should be, and Git can't resolve it because it doesn't know which exponent it needs to be. It doesn't know which of these 2 text versions should be the thing that should be merged, and that comes down to the engineer. So yeah, there's not really much to it. Some other cool things would be git diff head. So we're here, I'm trying to find the difference between head, which is like the start of the repository, or the current version of my repository, which is these hashes. This is, you could think of it as like steps. So this head here points to this commit, and the commit at this snapshot, and all of the changes that make this snapshot a thing is what head points to. If you've written a linked list, the terminology of head and tail will make sense. So it's kind of it's a linked list. So anyway, so then we can do git diff head and this tilde, and an integer here will go back one or more, or the integer number of levels. So you can do, if I do git head 1, I show a diff of just the change from the most recent change. And if I do 2, I can get the last 2 changes. And it's kind of a cool way, if you had a really long, big history, this is a cool way to just kind of pare down to see what you really need to see. So git log, git diff head, what else? Here's another one that's kind of helpful. If we do git log name only, will also show you the files that changed, which is often helpful. So that's kind of nice. Yeah, that's basically it. So there's nothing to be afraid of. Git's a really cool tool. If you can just get into the habit of, oh, I didn't know this was, I guess my Git is set up to be with my work email. Interesting. Oh, right, I set that globally. That's a rookie mistake. But anyways, so yeah, Git's not something to be afraid of. It's something to learn, to get used to. There's lots of really good functionality, and it's really helpful once you get used to it. It's not really that crazy. Usually most teams and companies will have a Git branching structure, like a workflow, or they'll have there'll be a framework from which you can work. But what you need to bring to the table is basic understanding of the tool so that you can learn how it's used. And yeah, post in the comments or write if you have any questions, and I'll see if I can answer those. Thanks.